Hi, I'm Chris Ward and I'm one of the product managers for the Control product business. And today I plan on going through the STS tool. So the abbreviation is the simulation tool for soft starters. So just before I go into that, I just wanted to explain to you that if you are having issues in selecting soft starters and gaining assurance into your selections, then this tool it would be really ideal for using because it basically takes the onus away from you. It simulates the application and then it suggests the suitable soft starter for that particular application. And it also takes into various considerations things like oversizing and overrating due to specific things like how arduous the load is, temperature, in terms of also the mounting can also affect the type of soft starter, whether you want to use it in an ATEX environment. And the whole idea of using the STS is that that onus of worry is taken away from you if you're using the STS in the appropriate way. So I'm going to show you where to find it and also how to use it. So what we'll do first is go into Google and type in Siemens STS tool and hit enter. And then the first thing that should pop up would be the simulation tool for soft starters in this ID here. So that's the technical support website. Once we click on there, it should take us through to the technical support website entry, where there'll be like a description, I guess, of the STS tool and some of the benefits and features of it. But what we need to home in on is how to download it, which is in an EX file. So if we just scroll down the page once it's loaded up, you can see here there's a setup file, an exe setup file, and that's the one that you need to download. So that's the one that you have to click on. So if you click on that and then go through the process, you will then have a shortcut which forms on your desktop, which looks a little bit like this. So it'll give you an icon which is for the STS tool. And if you double click on that, it'll then take you straight into the STS tool homepage. So from here, there's a few different things to look at on the homepage. You can add a new simulation through here or through this calculator. You can open an existing project. You can go into settings and change the language, or you could even change the system units if you wish to. And there's also a really cool tab here, which is for help. So if ever you're looking at gaining a further understanding of how to make a soft starter selection on your own, or if you just want to know how the soft starter tool has calculated certain things, then this help key is perfect for that. That's where you find all that type of information. So we'll just X that down and we'll go into creating a new simulation. As I say, there's two different ways to do that, either here or here. So this tab will take you through to the home page. This tab will take you through to your simulation. This tab shows you how many soft starters are suitable for the application. Now at the moment that's 0 because we haven't actually put any information into the unit yet. So we'll go and create a new application now. Once that's been done, you will see now there's 3 different pieces of information which it's asking for. Environment and the supply, the motor and the load data. And as we fill out those 3 boxes, that disk should change in number values into which soft starters are suitable for the application. The other thing which I'll draw your attention to is the data quality. Data quality is also reassuring to your customer or to yourself if you are the end user, in terms of how accurate your selection is based on this information. So I'm going to show you how to achieve the highest degree of accuracy. And firstly, you look at environment and supply. So for the UK, we'll go for 50 Hertz. We'll go for 400 volts operational voltage for the UK. Environmental conditions, it provides these because you have to consider oversizing the soft starter if you go above 40 degrees in the cabinet. Similarly, if you go above 1,000 meters in altitude, you also have to consider oversizing the soft starter. But if you type that information into the STS, it'll take care of that for you. So the next tab is motors. So you have to type in the motor characteristics. So firstly, you input the rated current or the rated power. So in amps, the rated current, or in the rated power, you can type in the kilowatt rating. So we'll go for 5.5 kilowatts. So as you can see here, it says that one has automatically been selected, and that poor quality has moved ever so slightly to 25% accurate roughly. To get that to go up further, what we have to do is select a motor from the database, which is down in this bottom right hand corner. So if we go into select a motor from the list, you'll then get an additional pop-up box which should provide us with an array of Siemens motors. So as you can see straight away, it's taken us to the 5.5 kilowatt motors which are available to us. All we have to do is select the one that we're using. Now in the database it only provides the Siemens motors, but that's not an issue because you can create your own. And you don't have to put all the information in if you don't want to, because you can copy a Siemens motor and then you can just tweak it where possible, just to make it match the competition's motor specification. But for ease of this application, we're just going to select this one from the Siemens database. And as you can see, once you've made that selection, the data accuracy jumps to medium. Now we're in the medium echelon. And another thing that I'll point out on this tab, which is very important, is the service factor. So on here, it gives you a drop down of a tolerance of the motor, effectively, is the service factor. So say, for example, if you had a 1.2 service factor on a 5.5 kilowatt motor, that would mean that the power rating has a 20% tolerance going above 5.5. So that would affect the overload setting and the thermal model of the device. So if you don't put that information in, that'll be an oversight. So that could give you the incorrect suggestion of overload for that particular application. So it's really important that you put the service factor in for the motor input data. Once you're happy with that, you can then go on to the load selection. So with the load selection, load is basically what application it is. So here there is a list of applications. You've got an array from pumps to presses, conveyor belts. Now, what I draw your attention to now is it automatically assumes that you have a moment of inertia of when you select load type, it automatically assumes a standard load type. So moment of inertia is the amount of energy it takes to get the spindle moving dependent on the application. So say for a pump, that has a 0.12 moment of inertia. Now that's relatively low, but it automatically assumes that as a standard load, it automatically pulls through the moment of inertia at being 0.12, and it brings your accuracy up to good. Say for example you selected a crusher, which is a more arduous load, obviously that goes up higher, so it goes up to 2.4 for the moment of inertia because that's a more arduous load. But for this particular application, what we're going to do is we're going to go onto the pump. We'll select the moment of inertia, which is pulled through as being good, but if we want to get that extra 25%, you need to know the moment of inertia. So you can go down here and you can type that in manually. And as you can see then, that bar then fills up to excellent. So once you're done there and you're happy with your selection. Not everybody knows the moment of inertia, but you still achieve a high degree of data quality with the selection tool by just using the method which automatically pulls through the energy consumption on the startup. The next part that we need to look at is the starting parameters. As you can see, that disk at the moment at 12. This application parameters is where you can gain an understanding of what you need to set the pots on the front of the soft starter to. So the majority of our soft starts have current limiting function. There's only one that doesn't. So if you want a 3RW soft starter that doesn't have current limit, if you untick that box for start current limit, you'll get more soft starters offered in here if it's suitable for the application. So if we untick that box, you can see it moves to 15, so that means that you can use the 3RW30 for this particular application. And we'll switch that back on for now. Now, in this tab, you'll see the two graphics here. You'll get a comparison for a direct online starter. You also get the soft starter comparison, so you can demonstrate the energy efficiency between a DOL and a soft starter. And then you also get the load line here as well. The idea is you don't want the soft starter yellow line to intersect with the load line. So if you adjust the current limit and change it to say 1.67, it intersects and it'll tell you that the motor won't start. So you use this tab to optimize the starting parameters. So you can change that and you can up it to 4, and you can rest assured that if you set your start current limit pot to 4, that you're going to have no problem during the startup. If you want to have a look at the voltage parameters as well, you can then go here, turn that tab off, current limit, and then you've got starting voltage. I want that to be 60%, and then I want the ramp up time to be roughly around 5 seconds. Once you're happy with that, you don't get any pop-ups that say the motor won't start. We can then go and have a look at which soft starters are suitable for the application. So from this list here, down this left-hand side, you'll see the 3RW30 basic soft starter, right the way up to the 3RW55. So that's basic up to high feature. So we don't actively promote any particular soft starter. It will give you an array of all the soft starts which are suitable for that particular application based on the unique features which you've suggested, which is great for you guys. So what I want to draw your attention to now is the parameters which are pointed out in this box here. So estimated starting time 2.6 seconds, maximum number of starts per hour 56, thermal load 2%, rated current of the soft starter 12.5, and the overload setting is NA. So at the moment we haven't asked for an overload, but we can if we want to. So let's just have a little look in the next tab, which is this additional functions tab. So if we go into additional functions, there's these two key pieces of information which need to be entered. So this is compulsory information which you definitely have to consider when you're selecting a soft starter is A, the number of starts per hour, and B is how long it's going to be on for within that hour, because it will affect the thermal loading of the actual device. So if we change that to 20 starts, the thermal load will change. See, it's changed to 36%. And then if we change how long the device is actually on for, that'll also have an impact on the thermal loading of the soft starter as well. As you can see, the thermal loading is now dropped down to 31%. Now, once you're happy with the number of starts per hour and the on period, you can then start finely tuning any special requirements that you need, if you do need any special requirements. So there's specialized mounting conditions, side by side or horizontal mounting. There's also various different starting modes besides voltage control, which you can have. There's also alternative stopping modes which you can have rather than coasting down, voltage ramp, pump stop, torque control, DC brake for circular saws that need to be stopped abruptly. Further to that, there's also things like motor overload protection if you want that. So if we was to take the motor overload, 3RW30 doesn't have a motor overload protection. And at the minute this is showing as being class off for the 3RW40. So if we tick that tab, it will eliminate the 3RW30s, and it'll also suggest what to set the overload setting to as well. If you want thermistor evaluation, you can click that. So this is where you can really start finely tuning what you need your soft starter to do if you want any additional functions. If you're new to the game of soft starts and you want an easy life setting a soft starter up, you can use this auto parameterization function, but that gives you the high performance 3RW55 because that's the only soft starter with the auto tune function. Once you're happy with those functions, you can then decide if you want comms feeding up to a higher level of automation. So you get a form of control, diagnostics information, input data through the communication network, and you can do that with a various different array of comms cards. We'll use a Profinet card. We can have an external or an integrated display. We'll have an external display on the front of our panel rather than integrated into the device. We want a 1 meter cable, and we also want an IP 65 door mounting kit to ensure there's no ingress coming into our panel. Once we're happy with that, we can then click the soft starter. Click the soft starter and decide on the control voltage, whether that's 110 to 250, 24 volts DC. Decide on whether you want screw or spring loaded terminals. Once we're happy with that, you then have a part number here which you can feed back to your customer. So you can save that project as a file and store it somewhere locally. And that's where this comes into play on the home page when you can open an existing simulation. Or you can go to order. So if you click on order, that will take you straight through to the Siemens MAL, where you can go and order the part straight away. Or you can generate a report here. Now, if you want to generate a report, you can click on mains feeder components. Now, with those mains feeder components, basically what that means is with the soft starters, you get a method in which to switch the motor on. You get the thermal overload integrated if you wish. So if the motor starts to overheat, the motor's protected. But there's nothing upstream of the soft starter protecting the soft starter. So how will we go about that? Well, if you click mains feeder components, it will offer you a suggested type of coordination, so a short circuit protection, either type 1 or type 2. For the UK or European market, or we'll also do the UL market as well. The difference between type 1 and type 2 is that if in the event of a short circuit, the person's protected and also the system with type 1, but not the soft starter. If you want the soft starter to be protected, you have to select type 2 coordination. But that's only viable in certain scenarios. So say, for example, if you were using a 5.5 kilowatt soft starter, and it's only a basic soft starter, the chances are if you use type 2 coordination, the fuses would probably cost more than the soft starter. So you wouldn't use type 1 coordination for a low level soft starter. Type 2 coordination. But if you wanted to use type 2, it'd probably be more viable where you're using, say, a 560 kilowatt soft starter which costs £8,000. You're going to want to back that up with type 2 coordination, because that's going to protect the device and you're not going to have to swap that out in the event of a short circuit. So once you're happy with either type 1 and type 2 and made a decision on that, you can then give your project a name, and we'll call ours test. Once we've done that, you can then go and edit the addresses in. So you can go who's it from, who's it going to, and then you can jump straight into generating the report and click generate the report. So once you've done that, you'll get a comprehensive report out of the STS tool, which will give you everything which you've entered into the tool to back up your project, and also give you an assurance in the soft starter selection. So once you're actually happy with the selection, you can now start generating the report. And once that's actually finished loading up, the best thing to do is to go from here and export that file into a PDF and save it. So once that's actually been saved, you'll then click PDF and you'll get this test format, which you can then pull in, which is comes in this type of format, which is much easier to read. And on the it's a 3-page document where you get everything that you filled in terms of who it's gone from, who it's going to, the supply, the environment, the motor data, the load data, any additional functions you've selected, the torque and speed curve, current speed curve, the soft starter part number and its characteristics, the commissioning parameters, the optional line contactor, say for example if you were using it in a safety circuit, and then all the additional accessories which you selected from the additional functions tab. So the comms module, the advanced HMI, the connection cable, and the IP65 mounting kit. And then to top it all off, you get a report at the end on the final page telling you why you reached that level of data quality and how. So it really is a great tool to use. As I say, it's free to download. It gives you complete assurance in your soft starter selection, so please start using it freely. Yeah, and I hope you got something from the presentation. And if anybody has any questions, please feel free to comment. Thanks very much for watching.